Let's get on the Azure portal and implement Azure Virtual Machine Scale Set in action. To create a virtual machine scale set in Azure, simply go to the Azure portal, type Virtual Machine Scale Set into the global search bar at the top, and then select the Virtual Machine Scale Set service from the drop-down suggestions. This will take you directly to the setup interface where you can begin configuring your scale set. This page shows the virtual machine scale set landing page in the Azure portal under Compute Infrastructure. Simply click the Create button at the center of the screen or from the top bar. This launches a wizard. This page is part of the virtual machine scale set creation process in the Azure portal, specifically on the Basics tab. It's where you lay the foundation for your scale set, and this is where you make most of your VM assess decisions. Let me highlight them. In the availability zone field, you are choosing how to distribute your VMs across the data center zones in your selected region. By selecting zones 1, 2, and 3, you are telling Azure to spread your VMs across physically separate data centers within the region. In this case, Australia East. Why does this matter? Because if one zone experiences a power failure or network outage, your other VMs in the remaining zones keep running, giving you high availability and business continuity. It's one of the best strategies for minimizing downtime in production systems. In orchestration mode, you decide how Azure will orchestrate the deployment and behavior of your scale set. Flexible mode gives you maximum flexibility. You can mix VM sizes, OS types, and even reuse existing VMs. It's ideal when you need to handle heterogeneous workloads or apply different configurations within one scale set. Uniform mode is perfect for running large numbers of identical stateless VMs. Azure automatically manages the instances based on a shared template, making it simple and scalable, perfect for front-end web apps, batch jobs, or microservices. Let me scroll down on the Basic tab. In scaling mode, you get 3 options for how your scale set adjusts its capacity. Manually update the capacity. You'll set a fixed number of VMs and Azure won't scale automatically. Great if your workload is stable and predictable. Auto scaling, which is selected here. This is the smart option. Azure watches key metrics like CPU usage and adds or removes VM instances based on load. It's perfect for apps that get bursts of traffic and need dynamic scaling. No scaling profile. Use this when you plan to manually attach VMs later or want to integrate with another management tool. Since we have chosen auto scaling, the scaling configuration section lets you fine-tune this behavior. You can configure when to scale out, when to scale in, and by how much. This helps keep your app responsive and your budget optimized. Let me click Configure here to customize these scaling configuration thresholds. We are now configuring one of the most critical aspects of your virtual machine scale set, auto-scaling behavior. This page lets you define how scale set should respond to changes in demand by increasing or decreasing VM instances automatically. Let's walk through what we are setting. Under default condition, you've enabled autoscale mode with this configuration. Instance count 220. 2 means you'll always have a minimum of 2 VM instances running, can scale up to 20 if needed, and scale in out by 2 instances at a time. CPU threshold 80%, 20% means if average CPU usage across your VMs goes above 80%, Azure will scale out. If it drops below 20%, it will scale in. This keeps your environment responsive while avoiding over-provisioning. Schedule. Right now, there's no schedule applied. We can optionally add time-based rules by editing this. You can check predictive autoscaling box if you want Azure to use historical patterns and machine learning to forecast traffic spikes before they happen. It's a powerful option when dealing with regular traffic surges like e-commerce events. If you want more insights into how your scale set is performing, enable diagnostic logs option. It allows Azure to collect diagnostics from the autoscaling engine, which helps with troubleshooting and auditing. Scale in policy defines which VM instances Azure should remove first when scaling in. The default setting balances VMs across zones and deletes the one with the highest instance ID. If you are concerned about stateful workloads or session stickiness, you might explore other policies for better control. You can also choose to force delete VMs during scaling. This is helpful when you want to avoid waiting for graceful shutdowns, but use this with caution. Once you are done configuring, just hit save. These settings will help you run a resilient and cost-efficient VMSS deployment that automatically adapts to your app's needs. We back to the basic tab for image. I have selected Ubuntu Server. This means all your VM instances will be based on this Linux OS image. Choose something that your app supports and that aligns with your team's operational skills. For VM architecture, I have gone with x64, which gives broad compatibility with most software packages. If you are chasing better price performance, up to 50% improvement, you might explore ARM64, but only if your workload supports it. Size defines how powerful each VM is. Here I have chosen standard D2SV3, which offers a good balance of CPU, memory and cost. You can also pick up to 5 sizes if you want the scale set to pick from multiple options, especially useful in flexible mode. These settings define how resilient, responsive and cost-effective your VMSS deployment will be. Scaling configuration ensures you adapt to real-world demand, and choosing the right image and VM size ensures your app runs smoothly on every instance. Let's click on Next now. This page is where you decide if you want to save costs by using Azure Spot VMs in your scale set. Spot VMs let you take advantage of unused Azure capacity at discounted rates. Perfect for batch jobs, dev test environments, or other interruptible workloads. You can choose to deploy your scale set using Spot VMs only, or a mix of regular and Spot VMs. Just toggle the option by selecting Turn on Spot to begin customizing your Spot VM setup. In eviction options, because Spot VMs run on spare capacity, Azure can evict them at any time if resources are needed elsewhere. This section lets you set the rules for when and how those evictions happen. In eviction type, capacity only means your VMs are evicted only when Azure runs out of capacity. Price or capacity means eviction can happen if the capacity is gone or the price exceeds your defined threshold. In maximum price, you can set the maximum hourly rate in USD that you are willing to pay. Azure won't charge more than this and may evict the VM if prices exceed it. In eviction policy, stop/delocate means VM stops and can potentially restart later. Delete means VM is fully removed when evicted. You can also choose to scale using both regular VMs and Spot VMs. This gives you more flexibility. Critical workloads run on regular VMs, while non-critical jobs run cheaply on Spot VMs. Just check the box under Scale with VMs and Spot VMs to enable this hybrid model. This setup is all about balancing cost versus reliability. If you are running workloads that can tolerate interruptions, enabling Spot VMs here is a smart move. Let's click on Next now. On this disk tab, you get to define the storage settings for your VM scale set. Azure gives each VM an OS disk and a temporary disk. But here's where you fine-tune the performance, encryption, and storage type to match your workload. Azure automatically encrypts your managed OS and data disk at rest. But you can also check the encryption at host box if you want encryption, while data is still on the physical host before it's even written to Azure storage. Note, this option needs to be supported in your subscription. In OS disk settings, for OS disk size, pick the size of the operating system. Disk default is usually 30 gigabytes. For OS disk type, select the performance tier like Premium SSD for faster IOPS or standard HDD for cost savings. For key management, choose between platform managed keys, which is easiest, or your own customer managed keys from Azure Key Vault. You can also enable ultra disk compatibility if you need ultra high IOPS and throughput for advanced scenarios. If your scale set needs to attach additional storage for databases or large apps, you can add data disk to each VM from data disk section. In advanced settings, use managed disk is selected by default and is required if you are deploying across availability zones. For ephemeral OS disk, choose this if you want super fast performance and don't need the OS disk to persist after the VM is deleted. Placement options like OS cache or temp disk affect where the OS disk lives, useful for stateless apps or dev test workloads. So this page is your chance to strike a balance between performance, cost, and resilience for how storage behaves across every VM in your skill set. Let's click next again. On the networking tab, you are deciding how your virtual machines will connect to the outside world and to each other inside Azure. First, you need to select a virtual network. This is the secure, isolated network where your VMs will live. Once you choose the VNet, you will then select a subnet, which is a segment of that network used to organize and isolate traffic. Each VM in the scale set will get its IP address from this subnet. Below that, you will see the network interface section. Each VM needs at least one network interface to communicate. You can use the default NIC created here, or configure a custom one if you need advanced routing, security groups, or multiple NICs. Then comes the load balancing options. If your VMs are serving web traffic, APIs, or applications, you can place them behind an Azure load balancer to evenly distribute traffic across instances. You also have the option to use an application gateway, which adds extra features like SSL termination and web application firewall. If your scale set doesn't need to receive inbound traffic from the internet or other services, you can select none. If you choose to use a load balancer or gateway, you will also need to select an existing load balancer or create a new one. Keep in mind, you must configure your network security group to allow traffic from the load balancer to your VMs. Otherwise, it won't work properly. In short, this page is all about how your VMs communicate with each other, with Azure, and with your users. On the Management tab, you configure how Azure will monitor, upgrade, and manage your VM instances over time. You'll start by choosing the upgrade mode. If you go with manual, you are in full control and will have to apply updates to instances yourself. Other options like automatic or rolling, when available, can push updates for you with minimal downtime. Next is boot diagnostics, which is useful for troubleshooting. You can enable it with a managed storage account, recommended, or set up a custom storage account if you prefer more control. This logs boot events and helps debug failed VMs. You can also opt to receive notifications, like when an instance is being terminated or reimaged. These are especially helpful in production environments where even a momentary loss matters. Under Microsoft Entra ID, you can enable login using Entra ID credentials. This lets users sign in using their role-based access rather than managing separate local credentials. It's clean and secure, perfect for large teams. The standby pools option is for workloads where speed matters. By enabling this, Azure pre-warms your instances, allowing them to launch faster when scaling. You'll need to assign RBAC roles for access. You also get to configure guest OS updates. You can toggle automatic updates for the VM OS to keep it patched and secure, though this won't apply if you chose a custom image that doesn't support it. Enable. Hot patch is another option for supported images. It allows Azure to apply security patches to your VMs without rebooting them, reducing downtime. Lastly, you can configure patch orchestration options, giving you some flexibility on how and when patches are applied to your VM instances. This page is all about long-term management. How you maintain, monitor and secure your scale set instances efficiently and automatically. Let's click Next. On the Health tab, you're setting up how Azure monitors the health of your application and responds to failures. If you enable application health monitoring, Azure will regularly check the health of your app running on each VM instance. This helps identify when an instance isn't behaving properly, like if it's crashing or returning errors, so it can be fixed or replaced. It's especially important if you're using features like automatic OS updates or instance upgrades, because Azure needs to know if your app is still healthy after changes. Under Recovery, you have the option to turn on automatic repairs. When you enable this, Azure will automatically detect and replace failed instances based on your health proofs. But here's the catch. You must have application health monitoring enabled first, or automatic repairs won't work. So, on this page, you are giving Azure the tools to watch over your workload and recover quickly from issues without needing you to intervene manually. This is a key step in making your deployment resilient and self-healing. Let's click on Next. On the Advanced tab, you are configuring deployment behavior, automation scripts, and how your virtual machines will be distributed for resilience and performance. Let's focus first on the spreading algorithm setting. It determines how Azure spreads VM instances across fault domains, which are isolated hardware groups within a data center to minimize the impact of failures. Max spreading distributes your VMs across the maximum number of fault domains available. This boosts high availability and fault tolerance. It's the recommended option when you want your workload to keep running smoothly, even if part of the infrastructure fails. Fixed spreading tries to place your VMs into exactly 5 fault domains. If there are fewer than 5 available, deployment might fail. This setting gives you predictability but may reduce flexibility and success rates, especially in constrained regions. You'll also see options to enforce allocation across zones, toggle automatic zone balancing, and define VM applications to automatically install during provisioning. Below that, you can input custom data for provisioning time configuration, like Cloud Init script, and user data for persistent configuration throughout the VM's life. In short, this page lets you define how your VMs are installed, configured, and spread out for maximum resilience, so you stay in control while Azure handles the heavy lifting. Click Now Review plus create, and your virtual machine scale sets will be deployed with all the configuration that will suit your use case.